Hi everyone, welcome to another Wolfram Language Design Review, part of our incremental language development series. And we have a few topics today. What is auto batching? I don't know what that is. Okay.
So yeah, we have a handful of primarily network-based functions that have to do some sort of automated batching for things like entity value, to a lesser extent parallelize, which
I
Tony
thought
has
we had
worked
this
on.
batch applied concept. Do we not have
Ye-
that?
Yeah,
Don't we have batch applied? Do we never implement that? How do we
Yes,
do this? What?
we discussed the design years ago, but we never implemented it or decided to implement it. Yes.
But wasn't that primarily for database lookup?
So the idea is that switching between map and function, you put something like batch applied and specify how big the batch size should be. Yeah? And that would, instead of mapping the function over, you would supply a list of elements, yeah, given the batch size.
Okay, I'm a little confused here. I mean, we've got, and I assume we don't have Roman here. Do we have Roman here?
we do not, but Carla, could you see if he's available?
Sure. Mhm.
Okay, so remind me, I thought batch applied was a thing that keyed into the relational database, etc. lookup mechanism. Am I wrong in that recollection?
I think so. So this is so far has been only an internal concept in the entity frameworks as an internal utility. Yes.
Well,
It is basically
so go ahead.
It is basically used in situations where you have to supply a handler function, and you can specify that this function should be applied to a list of elements instead of a single element at a time. That means it allows you to reduce the number of handler functions that you might have to handle, either one for a list or one
Yeah, I
for a
get it.
single element.
Okay, let me see what you have here. I'm somewhat confused.
So this is yet another proposal.
I'm sorry. So
Yeah. So this is basically when you have something like a listable function, but you notice that supplying the whole list is too resource intensive. Let's say it uses too much memory or timing, and then you might want to break it down, not to one element batches, but to some intermediate batch size. No? And that this function handles calling the batches, but also making the batch size smaller if there's a failure.
okay, I'm somewhat confused. So so
Roman is here, sorry.
Okay. There are functions like entity value that, if I'm not mistaken, so walk me through entity value and how it deals with batching.
Yes, so it's an effectively listable function, and you can supply an arbitrarily long list of entities in the first argument.
So let's try this. So let's say I say countries in Europe, let's say, okay, and then I'm going to get a list of countries, and now I'm going to take this and I'm going to say here, I don't know what, number of airports. Okay, so now you're saying that this will automatically do a batched lookup. Is that correct?
Yes. In this case, all at once, but as soon as you're getting in the hundreds, then it might break the things down in smaller lists. Yeah. And put the result back together, which is easy in the list case, but harder because you could specify a list of properties there, and then you have some kind of outer product of entities and
Okay,
properties.
so let's look at a case that I was looking at. So let's say, okay, so if I say alkanes here, I just did this yesterday, then, and I say here, so I could have exploded that with entity list. It'll be a few hundred items, right? And then it doesn't, why is that wiggling like that, by the way, when I mouse into that? I mean, I hate to bring up a different thing, but
Yeah,
that
when it's
wiggle should go
bolding,
away.
it's kind of wiggling. Okay,
Yeah,
I'll take a look at that.
that wheel should go away. Okay, in any case. Oops. Oh gosh. This is the case. Okay, look. Okay, watch this for a non-batched situation. Okay, so let's say I say this. It's going to say floop, didn't work, right? It probably should have worked. This is a thing we should report to the chemistry team. Can somebody do that, please?
Yep.
But this is the, okay, so now let's try this. I don't know why it says it isn't a list of molecules, but anyway, I think if I say rest, because that for some reason liquid methane is not. Yeah, I don't know what the heck it's doing here. Now, on the other hand, if I say molecule graph / at this, it will work, albeit very, very, very slowly. And by the way, do we have the version of Monitor up and running now that works in this case? Can I try
No.
this? Okay, so that didn't batch. But do I have a hope in hell of getting it to batch? Do you understand my question?
Yes. So there's something in the works for the case of entity, but in general, how that would know which things to collect, that would be hard.
Yeah, but I think that molecule graph, I mean, something is wrong here, but in this case, well, okay, by the time the function is listable, it's up to the function to deal with making sure that it's efficient when it's given a list.
Mm-hmm.
Do you agree?
Yes.
Okay, so what is the case that you are handling here? The function is not listable, right? So if it isn't listable, I don't understand how you ever feed it bigger chunks. Do you see what I'm saying?
You mean entity value or the functions that don't support lists of entities?
Well, are you saying this thing is only for entity value?
Yes.
That's where it's currently used. I
And
mean, the
yeah.
application, the idea here is to have a framework to make batching more accessible, something like the progress monitor framework where other functions could hook in and say, okay, rather than molecule plot rolling its own batching system, if it in theory works on a list of entities but may want to batch them together into reasonable size requests, having something like batch map with retry, even if it's a internal utility, would potentially be useful.
Okay, let's cover that in just a second. What was the statement about monitor with one argument with map? What's the status of that? Because that's really an important thing.
It's in the prototype build. Julio and I need to meet to work out some details, and because of scheduling and me being out, that hasn't happened. So it's in the prototype build, but it's it hopefully will be merged, not too distant future, but it's it's not going to be in the next few days.
Okay, fine, great. Okay, let me try again to understand what you're asking for here. I don't get it. How this thing, I mean, what do you need to have for a function so that it can use batch map with retry?
So in the case of entity framework, it handles batching for you. Now let's imagine someone is trying to implement a service connection or something like this. Then they might have to handle long lists of requests, and then they would implement their own batching, probably start with partition of up to 500. And then worry about failures. Yeah, and all of this logic of handling failures is baked into batch map with
Okay. So
retry.
what you're dealing with here is listable functions, basically. You are giving listable functions smaller lists to eat than they would naturally have. Is that correct?
Yes.
Okay, so this is a, I might have a function f of, range of 100 or something. And what you're doing is, instead of feeding that all to f, what you're doing is you're saying, I'm going to feed this in chunks.
Exactly. Mhm.
Okay, so this is somewhat complementary to parallel map,
Right.
right?
Yeah.
Same general idea, but now you could imagine parallel map doing the same thing, that it says, I'm not going to send these individually. I mean, no, it isn't quite parallel map. It's some kind of parallel thread, parallel map, listable. It could say, I'm going to do one of the first 20 things in this F on one processor, the next 20 to another processor, and so on. Am I making sense?
Yeah, I
Yes.
think the obvious use cases for it are things where communication overhead is a factor, so parallelism, anything network operated, and where we can't necessarily process everything at once. So I think
Yeah, I
what is
understand.
it?
But I mean,
Parallel
this is
submit and wait all is another kind of like batching, a manual batching system, if I remember right.
yes,
I mean, parallel map and friends do that kind of load balancing by themselves. So they usually hack the input into certain pieces and send those pieces to individual kernels. And so that is under user control. So whether you want small batches and more control over the scheduling, or whether you want maximal batches and minimal communication overhead.
okay. But
I
so
think, right.
go
So
ahead.
I think for anything, right, this wouldn't be useful for anything where we don't have, you know, uh, sort of some sort of external constraint, I think, right? Because, parallelize talks to other kernels. I mean, here we're in
Exactly. We're talking to some.
we're in a single kernel, and right, the kernel is not magically going to become multi-threaded after
Exactly.
years. And so, if we have some sort of external constraint, like here, we're talking out to the alpha servers, sort of controlling the batch size makes sense. If we're just doing a computation in the kernel, well, may as well
So
just
what kind
flip
of parallelism? I mean, if you have a single kernel, then what is the? I mean, I'm lacking some background here, but what is the issue? I mean, what do you gain by
Okay, let's go
batching
through this.
things
That's
in
a
a
good
single
question.
kernel?
That's a
So
good question.
I have an example. For example, the geofunctions can send arbitrary lists to the geoserver, and in many cases, we will just get a timeout. So a framework like this could be helpful in organizing an option or a wrapper function that allows the user to say, oh, my connection is bad. So send them in batches of 10, batches of 100.
Well, but where's really the limiting factor? The thing's being sent to a geoserver. The geoserver has a timeout per query. So if
Yes,
you send it, 1,000 places or something to process in some way, it's just going to time out.
exactly.
So essentially, this is a throttling mechanism
Mhm.
because you don't want to send the whole thing. Now you could say the geoserver itself should queue those things, but this is asking the client effectively to do the queuing.
Right. I think it's giving the user the control of how many, because the user may have experience and or may want to control things.
Right. And
Right.
right. And the second factor, right, the reason this is beneficial, right, is that there is a startup cost, right? The reason why we don't always send exactly one place at a time is that, then we're bearing quite
Sure, exactly.
startup and shutdown costs. Whereas,
Right, but
so
just so I understand the semantics here, basically what's happening is you've got this list, you're breaking it into chunks, you send a chunk, there's a blocking operation to send the chunk. You wait for that chunk to come back, then you send the next chunk. Is that correct?
Yes.
Okay, so that's in a sense the exact opposite of what's happening in parallelize, where you try to send the chunks in parallel.
correct.
Okay. And
It's a way of sort of auto negotiating the chunk size.
Yeah, it dynamically rescales it. So like if you ask entity value for the populations of every country, those are relatively small values to come back. If you ask for the polygons, the internal logic in entity value will rescale the batch sizes because it asks for 100 and it times out or something like. I mean, it's more intelligent than that
Yeah.
in that it knows roughly what size some of the properties are. But if you're getting a lot of data back, it will trim down the batch sizes automatically, which is kind of what you can see in that echo example right above what you have highlighted, where it starts
Okay.
with a batch of 3, and then for some we're simulating a failure, and then it scales it down to 1, and then batches of 2, sort of
Yeah.
like what URL.
Yeah, so yeah, the logic behind that is that if you fail, then scale down a lot, and then if batch is coming back fast enough, then you might still try getting up a little bit again. No, so you divide by 4, and then you multiply by 2, and see until you reach a certain threshold.
Yeah, okay. I don't understand why this batch map with retry, I don't understand why it says map of F there. Why isn't it just F, comma range of 5?
This map of F is just to simulate a listable function. Because batch
Not
map
really.
with retry expects the result to
should-
be a list.
Shouldn't have map in the name though, because it's really batch apply with retry.
Yes.
It's similar to subset map, where you
No,
map
it's
over
not.
subsets.
No, I don't think so, because no, I mean, look, the conceptual thing that's happening here. Okay, first point. This only works with listable functions, correct?
Yes.
Because it needs a function. You know, the requirement is it's a function that can take a list of any length as input. Correct?
Yes.
Otherwise, this is dead meat. It's not useful. So now what this is doing is it's asking, I mean, I really would have thought that this should be a headdress to the function itself. That is, that what it should look like is much more like, you know, batch applied, F, comma, and then here it can be the batching parameters of, you know, whatever it is, range of 20. See what I'm saying?
Yes.
It's really a headdress to that function, isn't it?
I think it's either that or a common option like parallelize that can be used in multiple places.
Parallelize isn't an option. Parallelize is a function. Parallelized. Is that right? What
Yes.
is the option?
I think there was an option, right?
Yes, some internal functions use various options to indicate internal parallelism.
Yeah, but what about how can you set a function to use internal parallelism or not?
Only those that support it. I mean, they.
Yeah, but what are those functions? What's the option called?
Sorry, I was confused. No, I don't think there is an option. It's
So it's just like the old compiled option to plot, which probably nobody will ever set. Because
There's
it works.
parallelization as an option just for the old compiler, as far as I'm aware of.
What the heck is that?
Oh yeah, that's old stuff.
Yeah, I've never seen it.
Really?
I
Oh,
thought-
We should
Oh.
retire that symbol. Make it possibly available for future use.
what does it even mean? I had no idea that was there. Okay, that's a separate thing to work with Tom. Roman, I think that's something for you to go chase.
I mean,
to
that's
figure
not
out.
the current compiler, right? That's the old.
No, I know, but I don't even know what
Okay.
this does. Let's not even worry about this. What is this?
I think this is activating or deactivating parallelization.
It looks like the old compiler already had some support for parallelizing, generating
Yeah.
parallel code.
I didn't know that. Maybe nobody ever used it. Maybe nobody ever
Nobody
switched
used
this on.
it.
I used to
Let-
use it all the time, but it's been years since I used it.
Roman, could you investigate this and just see
Mhm.
what the story is? I mean, maybe we set this up, 20 years ago before most people had multi-core computers, and we've just never enabled it. That would be crazy. Let's find out. Okay, in any case, what we're looking at here is something I think more like this, isn't it?
Is that 3 your starting batch size?
I would assume so. Or something. I mean, there's some options here for batch, how the batching works. And then this is just essentially an adverb, a headdress, to say how F is getting applied. And it's saying use all of this fancy technology to, you know, do what otherwise would be a pure. Now, I mean, in the case, okay, so I don't really understand why. Oh, I see. The map thing is pretty weird because that's going to do it element by element anyway.
I wonder whether we have to worry about individual arguments, like batching in the first argument or the second argument or something like that, like entity value.
I see, I see, I see. Tony, what do you have to say about that? Which argument are we applying this to?
Yes, so that at the moment that would be in this design, it would be handled with a function that takes one argument. Yes. That
Yeah,
means
but
a
entity value
pure,
is not such a thing. I mean, entity value
Yeah.
takes two arguments.
So this one is a more special thing. It's not listable. It's more like it takes a list in the first and the second argument, but it's not listable in the sense of expecting the same numbers of entities and properties, but rather does an outer. Yeah.
Yeah, there's another subsection there on batch outer.
This is a mess, guys. Sorry. I'm sorry. This is not. You're basically talking about single argument functions here, which is not clear.
Maybe it should be like threaded, which also works on listable, right? So instead of batched applied, it would be batched, and you apply it to a list, and then you use it within some listable function.
I was about to think of something. Yes, I was about to. That's a, you know, so you say for batched and then range of 1,000.
Yeah.
That seems much cleaner to me. I mean, implementationally, it will probably work without values and things, but that's a different issue. This seems interesting to me. You could even have two different arguments that are both batched.
Right.
How would that deal with the batch outer? It would deal with it, right?
So it depends on the function that accepts two list arguments. So would that be a listable function or not?
I would think so. I mean, I don't understand what does the batched outer do?
So it effectively does outer, but supplies two lists to the two argument functions. Yeah. I think that would maybe go a little bit too far for this initial batching meeting. It's
No, but we need a design that's general. So I mean, the issue is if you had two look, let's take the entity value where you have both a list of values and a list of properties. Okay. Is it the case then that you could essentially do the equivalent of batched entities, batched properties, or does that not work? Is there something you have to do that's different from that? Let's say you did that.
what would the batches be?
Or whatever they need to be. I mean, are you saying that there are cross-product batches? Okay, you've got a
Yes.
rectangle. Okay, you've got a list. You got a one-dimensional list. The batches are getting chopped to a certain size, right? That's what you're doing with this batch
Yes.
applied thing. Okay. Now you are looking at a two-dimensional array, and you're saying, I somehow want to batch the two-dimensional array. It's much less clear how you do that. It's much less clear whether, if you're not independently batching rows and columns, how exactly do you?
Yes.
You know,
So yeah, you can imagine a grid and then going along line by line on the grid. And then there are the interesting cases where the overall batch size is smaller than the width of the grid or larger.
well, I understand, but if you, okay, so the question is, what's the space filling curve basically that walks through the grid,
Yes.
right? And if you are going line by line, something like this is basically going to work. Right? The only case where that wouldn't work is if you want to have blobs that are beyond a single line. Right? Or that span multiple lines.
So in the proposed example with batched of ends and batched of props, you could specify independent batch sizes, I assume, like 10
But
ends
obviously in
and
this
2
case,
props. That means requesting 20 values at a time.
sorry, in what case? You're saying, look, go ahead, what?
The highlighted example, yeah. So probably
yes, you could obviously give different parameters in the batches.
Yeah.
Well, okay. This seems like an interesting design idea. My question would be, I think it will be vastly more common. Jose, maybe you can comment on this, to be just having a single batched.
Yes, I think so. But I mean, it would be very interesting if this works too.
Sure, but there's no reason why this can't work. The only
Exactly.
question is whether it's an outer product here or whether those two batches can interact with each other.
I think I would start by doing some sort of double partition, and then each one will live under control of the batching system.
Sorry, say that again, Jose. What?
Yes. So this is like a double partition. We start with little matrices, sub matrices of the full space, and then if that's still too large, the batching system should handle it in some way. We don't care how. We just indicate like some sort of beginning of the batching, and then the system will do the reconstruction, the flattening, the array flattening.
So what is the connection between the word outer in batch outer with to I and the inner outer?
What do you mean inner outer?
I mean, can you say batch outer with to I of inner product, or
I think that's just doing like a partitioning of the matrices of the matrix in sub matrices, and then F is being handled is handling each sub matrix.
Yes, but what kind of functions does batch outer with I handle besides outer?
Yeah, it handles any function that takes 2 lists and
Okay.
returns an array of the correct dimensions or matrix. Yeah.
Mm-hmm.
Sandra on our live stream is commenting that in image rendering, people sometimes do successive blocks on a Hilbert curve. I don't think we care about that in this case. Probably. Well, I don't know. That's an interesting question. I mean, if we were doing this for images, if we ever wanted to use this for dynamics, for example, then we might care about the visual ordering of things. Did that make any sense?
Yes. If we were presenting the results dynamically, I think we would care about the order.
Yeah. So, I mean, the combined ordering here of those two batches might want to interact with each other, is basically the point. But these are factored things I think we can deal with. The question is, what happens if we want them to interact? Is there any syntax we can imagine to having them interact?
Could you have like a single batched wrapper that's holding all the arguments where you can specify how it interacts?
Yeah, but how would you do that? Because batched is a multi-argument function. I mean, you'd have to have a batched sequence thing.
Yeah.
Well, I mean, you could do this. Rather bizarre. Wait a minute. Actually, hold on a second. We have the concept. No, we don't quite. I mean, we have the concept of we have this concept, right? But so almost what we'd be looking for is something like batched sequence, nth props, and then some complicated, Hilbert curve thing here, and then say f of that. See what I'm saying?
That it would basically auto flatten after batching.
Yes.
Yeah, I think certainly the basic case is probably where you're only batching a single set, but there are cases, for
No, so the
things
question
like
is, can we
entity
have the syntax be extensible? I mean, because the second argument of batched is going to be its
parameters.
I mean, unless the second argument of batched, I think you're going to want the parameters all the time. You don't want the parameters to be options.
Right.
Is there any? Okay, here's a bizarre idea. Here's a bizarre idea. To use splice as a holder inside batched. See what I'm saying?
Such that it would batch A, B, and C independently?
No, it would batch them together. It would do a
Okay.
combined batching of A, B, and C, but
Mhm.
then it would splice them into the outer F when it did the unpacking.
And so F would always see 3 arguments, right?
Exactly.
Yeah.
I think this is reasonable. I mean, it's a somewhat corner case, and I have wanted to extend splice anyway to deal with other functions, other than just list.
Does deal with other functions.
Yeah, it takes a second
As
argument.
an
right?
argument.
Oh, okay, fine. Well, then this is a perfectly reasonable thing to do, it seems to me.
Okay.
So,
Okay, so then
I'll admit I got a bit lost here. So what are we suggesting that this splice here does? Because if it's just sticking things into a list, then it's not changing its meaning and it should just work. But if it has some different meaning that's different from just splice, then
here's what it does.
That's
Here's what
weird.
it does. Here's what it does. Okay, that does that, right?
Yep.
The whole point here is this is not a pure splice, it's a batched splice. And what does that mean? That means that the batched is going to do some fancy footwork feeding different submatrices of ABC. ABC is some tensor, right? Rank 3 tensor, let's say. Okay, they could be even deeper lists and so on. Actually, that's another question, is when you say batched, if you just say F of batched of X, if X is a rank 5 tensor, what does it do?
I think you'd have to give a level specification too, right?
Yeah, so I mean, there's two different ways. Tony, have you thought this through? There's two different ways that batched can involve a traversal, okay, a non one-dimensional traversal.
Yes.
Case number one,
Mhm.
the thing that you feed it is not, it might even not be a rectangular array. The thing you feed it is a deeper array. That's point one. And point two, you have essentially the outer product of multiple arrays fed as different arguments of the outer function. Do you agree?
Yes, I have to think about this. So, yeah.
Okay, look, we'll write about this, okay? I think this is a reasonable way of handling the somewhat corner case of multiple outer, wanting to co-batch, so to speak, multiple function arguments. Do you see what I'm saying? If you want to outer
Yes.
product batch them, this will be fine, right? If you wanted to co-batch them, you have to do this.
So you're using splice here as sort of an inactive of map thread.
I guess so. I mean, it is the same meaning as a splice. It's just that, this will be a no-op. If you had this splice here, we could put the F there if you really wanted to, but I don't think it's necessary. If you had the splice there without the batch, this will be a no-op.
Yep.
Right?
Mm-hmm.
But the whole point is because you want to diddle with how this is actually being done, you put in a splice so that you can feed it in one gulp to batched. I like this actually.
Yeah, I
Good
can see
idea,
it being
Nick, on the batch
useful.
thing. Yeah.
You're working with some service that's column major, and so you don't want submatrices. You want the batches to go across the properties or whatever you're querying, but you want it to be subslices that don't mix multiple columns.
Right. Okay. So now the only question is, I mean, there's presumably a bunch of arguments to batched, like timeout options and things like this. Right?
Yes. So there need to be certain signals to indicate what went wrong if a batch failed. Yeah. So that can be timing or memory used.
Okay, that's fine. But there's got to be multiple pieces here. So, for example, if you've got even a rank 2 object in f of batched of x, right? You have to say, how are you going to, what are you actually going to feed in? Are you going to feed in, if f is listable, okay, just to remind ourselves, if f is listable, what's a good example of a listable function? Sine or something, okay? It drills all the way down. But we could be doing that by having sine of list AB, comma, sine of list CD, could we not? Right? In other words, or we could be doing the sine of the whole thing. We could be breaking it in a whole variety of ways. We could also be potentially breaking it in columns. Am I making sense?
Yes, but let me make a comment here. The idea of batch applied was leaving the responsibility to batch applied to control the whole thing. Here we are leaving the responsibility to the outer function to look for the batched and do things. So it's slightly different.
No. I mean, look, it could be some up value. I mean, the main point is, this is going to create, having the batch there is going to create a bunch of f of various arguments, various lists. It will then evaluate those and reconstruct them.
Yes. So we cannot have, for example, f of list of batched.
That's
it would be
correct.
too deep.
Yeah, that's correct. It's a top level argument thing.
Yep.
Which I think is just fine.
Yep.
I mean, just like listability, if I said f of g of a list, it's not going to know the inner list inside g. I mean, it's not.
It's just implementationally, this is different. We need to, for example, if a function gets too batched and they have different options for error control, it's not so clear what to do.
I understand. It's okay, but so then you need a specification of what are the specifications of batch? In this case, batched. What are the things? What are the second arguments? What's the second argument, Tony?
The second argument to batched would be the initial batch size, I say, or the maximum batch size. No?
Well, which is it? Is it initial?
let's say it's the maximum batch size, and optionally you could also specify an initial batch size.
Okay. But then, okay, and then you've got things like timeout, arrow, whatever.
Yes, but there are typically two. If you are timing based, then there are two values. One is the high timing, which means you're getting close to some time constraint, and the low timing, which means you can start increasing the batch size. Yeah, let's say if the network recovers.
Well, in that case, we should probably have, if it's that ornate, we should probably have an association with a bunch of those parameters.
Mhm.
I think this is a decent thing.
I would
Okay.
think level spec would be a more useful second argument, at least for the type of things that I could think of using this for.
I mean, I have to say, I think the batch size, what is the real point here? What's the real point? The real point is, okay, so one approach is just wait for it to fail. Pick an initial batch size, wait for it to fail. And the initial batch size could be there is no batching at all. But the problem with that is there could be a timeout. I mean, you could do that with a time constraint, with a default time constraint.
Yes.
But the thing is, the remote service might be upset if you send it too big a batch.
Yes.
Like it might block you.
Yeah. And another use case is if you're, for instance, trying to implement those kind of regular batching, rectangular batching in terms of linear batching, then from the first line, you might have learned what a good batch size is, and you feed that to get the second line done more directly.
Okay, but this is all the reason why batch size is a complicated issue. And maybe the right thing to do is indeed, as Rick's saying, to put a level spec in the second argument, which is clearly useful, and then to have all these parameters about how the batching is done be in an association. Am I making sense?
Yes.
Initial batch size. Arrow blah.
There could be things about like batching methods, like if it's rectangular, maybe you want to do like AD trees or something.
Yes. Or Hilbert curves or whatever.
Yeah.
Batch ordering David Hilbert.
Or handler functions.
Yeah. Okay. Roman, do you have any comments about this based on your experience with Parallelize?
Well, I mean, in Parallelize, it's all about the batch size or the number of batches, but there isn't any ordering or stuff involved. And we're still trying to figure out for which applications this elaborate mechanism is actually used.
Okay. The basic thing is you're calling a GeoServer. The GeoServer has a built-in timeout. You can't call it. It is efficient to call it with as many places, for example, at the same time as you can, but you don't want to give it too many or it's just going to time out.
Yes.
You don't want to give it too few because there's too much startup cost.
That's exactly like Parallel, right? I mean, there is no timeout, but the startup cost and the communication overhead. And there's an additional level in parallelism, and that is load balancing, right? If you have uneven jobs, you want to have a lot of jobs so that they can schedule themselves. But if you have small, even jobs, you want to have as many as possible to minimize communication costs.
So this is, coarser grained, finest grained, item square evaluation. This is somewhat similar kind of issue here. And it's interesting that there you're putting those things in a method option, and maybe we should modernize this and have an association as a possible thing there. I'm not sure. But in any case, it seems like one should just build out whatever the batch thing naturally needs. But that's the case of interest, right? Is okay. So what do you know, for example, for the GeoServer? What can you say, Jose, about the parameters? Because you know what its timeouts are, probably.
Right. It's about the 20 seconds of alpha in general.
Okay,
Yes.
fine. So I mean, since you know that, I mean, and you know, my question is, let's say we have a service and we have a system services entry for that service, okay, or a service connection entry for that service. My assumption would be that that service could advertise its batching parameters. Am I making sense?
Yes.
Mm-hmm.
So the best thing for batch to do would be to somehow know, you know, this is the service that's going to be used by, I don't know exactly how that communication happens, but that would seem to be the most sensible thing to do, even if it has to be hard coded somehow in certain cases. I mean, that would be the nicest thing, right? You know, if you change your GeoServer, that it would advertise different batching parameters and the batch would do something different.
Be some sort of like service connect data or something. We know what the parameters are when talking to Alpha versus this GeoServer versus
Yep.
OpenStreetMaps or whatever.
So,
Could
so,
this-
so that, yeah.
It could even just return the association. That would be the third argument.
Could
That-
this
that-
Sorry,
also
how would you return it?
rate limits and
Yeah.
automatically pause as necessary too?
Yeah, I was just thinking if
Yeah.
there's some way to, curate that data, then you could have a lookup function, service connect data or service batching data, even if it's an internal thing, and it could return basically what the third argument of batch would want.
Exactly. That's what I'm suggesting. Yep.
There are also other strategies. For instance, a service can return a partial result when it knows of itself that that it can't handle the whole request. And then there are also
I
different strategies. Let's say a key to continue the receiving results, or the other is simply return the overall size and the recommended batch size, and the function knows how
All
to
right,
handle
listen.
that.
I think we have a winning general concept here. Many, many details to fill in. Okay, but I think we've got a direction for the design. Sound
Okay.
reasonable, Tony?
Yes.
Okay, let's move on. We don't have much time left, so let's
This
optimizing
is
table.
this is a somewhat related, if kind of the opposite problem of another collection where we have a suite of functions that do some sort of network operation, and they are optimized where if you feed geo-elevation data, a geoposition with a bunch of points in it or a bunch of geopositions, it knows how to send them to the server and return one result with all the bits of data. But it's not uncommon for users to put geo-elevation data in a table and suddenly everything's way slower because it's doing them one at a time. And this has come up, this happens with entity value users periodically. And so I think there had been a thread proposing that, we should have some way to optimize inefficient code that users put in, or at least provide some sort of warning about it. This is a pretty trivial example here where we're putting an up value on table that says if you call table of geo elevation data, then we will invert the argument so it's geo elevation data of table.
Look, I think if we could do this automatically, it would just be a huge win. I think doing it automatically with a warning message might be maybe even the best thing we could do.
Something like,
Right, except I mean, right, we can't do this automatically. I mean, in this trivial example, sure, but if there's anything in between the
Yeah, I
table,
understand. Right, if it's computing something there. Okay, question. In a given input line, could we accumulate? Could we know, oh, the person's done just a gazillion geo-elevation data calls?
I mean, I think this is a problem for code assistants, not for the evaluator, right? If we ran every possible analysis to try to optimize code, right, be
No,
a
we
much
can't do
slower
that.
system.
Yeah, we
Right.
can't do that. But what I'm asking is this. Let's say that the server, the external server, knows it's being hammered. Okay. And it
Mhm.
knows that it is batchable.
Yeah, I mean, we tried to have a system like that for entity prefetching, right? Where we would say the, entity value used to track and say, oh, you've made 5 separate calls to country flags. I am going to asynchronously queue off a job
Yeah,
to
what
go and
happened to
download
that?
this and batch that. I guess, Tony, if you're still here, maybe you can give a better summary than.
Yeah, it's not functional, but I'm working on an overhaul of that system. Yeah.
Which will asynchronously prefetch, right?
So doing that asynchronously is not so easy. There are various design issues that have to be solved to do that asynchronously. So a first prototype will be synchronous, actually. Yeah.
Well, how could that possibly work?
So if you first use a domain, then it might just prefetch it if it is small. And for the large domains, it might want to ask you first, while this is running, do you prefer prefetching the whole domain, which is of
No, you can't do that. You
Yeah.
can't ask. What
Yeah,
are you going to
yeah.
do? You can't ask. What's that?
I was agreeing that you can't ask, right? I mean,
Right. The
so
only
this
thing
is
we can
running
do,
in a headless server, right?
yeah, it's just you can't ask. It not going there. It won't work. The one thing you could do is, which I think is the right thing to do here as well, is the possibility of a disappearing blue, progress monitoring type thing that says more or less you're running a lot of separate geo-elevation data things. By the way, you could do this, but it disappears at the end of the computation. By the time the computation is finished, you've swallowed the pill. It's
Yes.
done.
Yes.
See
So
what I'm
so
saying?
my proposal goes into the direction. Let's say if you do an implicit entity class lookup locally and it's downloading a lot of data, there's already some blue box, and that blue box could, for instance, receive a button that says, "Well, just download all of that domain." Yeah. So yeah.
I
But
see.
about
No, that's
doing the
reasonable. I mean, so long as it's there. Look. Yeah, that's a good idea. Okay, so if it's being hammered and it can see, in the case of this geo-elevation thing, I mean, well, this one isn't really a prefetch type situation. In this case, it could bring up a box that says, more or less, running lots of geo-elevation data. By the way, you could, put it the other way around. See what I'm saying? That would seem to me a useful thing. Okay. Here's the basic principle. If you're sitting and waiting for something, then giving you advice about what you should be doing so that you don't have to wait the next time around is going to be a win. Do you see what I'm saying?
Agreed.
Right.
And it's harmless, because by the time you finished, it's like, look, I was only doing this once. I don't really care that I could optimize it. I've done it now. So I like that idea of watching, basically, it's a general principle. When things are slow, if we could tell you how to make it faster, we should show that information as kind of a light entertainment while the thing is running.
Right. And that's, I mean, right, that's the sort of thing like, geo-elevation data could check, well, have I been called 5 times with the same dollar line, and then issue
sure,
or something.
Yes, that's what I would imagine.
But what about having this particular value there, which seems like relatively safe? Is this acceptable? Or is there any danger?
Thing?
So the particular value for geo-elevation data, only that one, is that safe enough to be there in the system automatically?
I think so. This particular thing, I mean, I think it's a little bit nonlinear to have, this case works, but as soon as you put an F around that geo-elevation data, it doesn't work. But I think if you combine those two things, I think it's reasonable.
Mm-hmm. Yeah, because it's an easy one. It's in the next line.
Yeah.
Mm-hmm. Okay.
Just looking ahead, and I know we're running out of time here. I just want to get a sense.
This one actually is very similar to the batched. It has some similarities.
It does. Well, it's kind of a right. I like that description. What are these?
Those just show you the actual values and their positions. And then and when you evaluate it, you basically do the out product of those values.
Okay, so there are two, I mean, this is multi could have the meaning that you're explicitly giving this list, or the multi is multiple possible. What happens if you have multiple ways to match, like with triple blanks and things?
Well, I have an example there.
Oh, there.
So yeah.
But there's two different ideas here. One is kind of explicit spatial multiing, and the other is, in a sense, semantic multiing.
Yeah, you can combine them together in some sense. I still kind of confused myself how it works, but there's an example of how you can use the values at certain position and the actual rules that act on a certain position that produce multiple values.
Okay.
And another thing, you can also have the actual evaluation also at multiple positions.
Right. I mean, okay, what does this do here? Where's the multi here?
Well, because you can apply your rule at all possible positions, right?
Oh, so this is a multi. This is saying that the multi can take a second argument, which is a set of transformation rules.
Yeah.
Is that what you're saying?
Sure, yeah.
Even though most of the time multi is just a fed wrapper, like threaded or something like this.
Really? Well, all of his examples have lists of rules, I think.
No, they don't.
Well, the
This
first one.
here.
Ah, okay.
So if I say f of multi here, what does it do?
Well, it will make a multi with an expression with f inside it.
That's what I thought.
Yeah. But it also only works when the argument is not held. Right?
Sure.
If you do the hold of multi, then it's not gonna do it.
Okay, but if I say this, oh boy. Okay, now what happens if I do normal here? Does it?
No, yeah, you have to make it careful. Unless there's a special up value for that, it's gonna go inside of the multi.
I see. It probably does need a special
Well,
value.
that's yeah.
There's
well,
an expression property. If you just ask for expression, you can extract it. But it's not gonna be useful in this case because the actual placeholder is gonna be returned. You might want to like evaluate list or a bunch of properties.
Okay, I understand. But the main point about multiing is, I mean, just to remind ourselves, the in a sense, the story of multiing is partly told here, where we do have a bunch of examples. Now, okay, so none of these, this is not a multiing story. This is simply right? This isn't where you're using multi. Multi is where you use
Well, you can still use multi for that. Basically, if you define a function f, or you provide an explicit rule for a multi, you make a multi object, and then you can evaluate it iteratively, right? So that you could iterate it once, it produces new expressions, and all the new matches are are pre-computed where the new rules can be applied, and then you can evaluate it again. Or you just ask some graph properties directly to construct this.
But usually, in evaluation, you are getting a foliation of this thing. You've evaluated to a certain distance, and you're slicing. I mean, in the case of fixed point evaluation, you're going to the end of this. How
Yeah.
does that relate to? You're saying that the multi could be just a few steps of evaluation. So you're foliating down through this, like in these pictures. So you could have a multi that represents a slice here.
Yeah,
That's
you
the
can
concept.
truncate it if you want to. You can iterate it again to make a new foliation. But yeah, that's effectively the multi-object itself represents one slice.
Right. But the multi-object represents a slice. It's the state of space, so to speak. It's not the space-time causal graph within the multi, correct?
Correct, yeah.
How do you keep the
can-
trace, so to speak?
Well, I don't keep the trace. You can
Okay.
just like keep all the intermediate multis somehow or extract it when the graph is evaluated. But I don't. Multi is
But
not.
how do you make this multi-way
made
graph
for
if
that.
you're not keeping the intermediates?
Well, just a function that just iterate this multi-objects many times, like 5 times
see.
here.
I see. So in that case, you are keeping the intermediates.
Yeah, in a way, yeah. Just some convenient functions that run the loop and store whatever you need.
By the way, just so I understand, given multi, how would you use that in the quantum framework?
Well, I wouldn't use it directly, right? It's not really analogous to any quantum computation directly like that. But maybe if you have some probabilistic representation of a quantum computation, then you can essentially use multi as a storage for actual instances of species that you iterate over and rewrite over. So that basically it acts as a instance of a probability distribution.
Yeah, right.
Right,
So it's
that-
like in probabilistic programming or something, there's a similar, except that multi here is an unweighted, like graphs, it's an unweighted thing by default. But you could imagine
Yeah.
decorating a multi to have weightings for every element. Do you
Yep.
agree?
Yeah, something like that. By the way, those values in superposition, they kind of can be copied freely because you can have the same placeholder multiplied multiple times, even though each of them represents many values. So in a way, you can use that maybe to
Well,
indicate
to get
this
discrete,
weighting.
yeah, discrete weightings. But I think it may also be useful to have, just like, in choice, in random choice, for example, you might want to be able to feed it a multi that is already a weighted multi. I'm not sure. We got more to figure out here. And I think this is a much bigger
Yeah, I haven't had time to dig into this.
No, we should not
proposal
discuss
that Nick-
this.
And for added bonus, Nick, string diagrams, is that what that tensor representation, is adjacent to or not?
Well, string diagrams and quantum circuits basically the same. Right. Well, quantum circuits is one instance of those, one example, or any
Yeah,
kind
I
of
know.
tensor network.
Exactly. But so what I'd like to see is what we can do. We've got various attempts at string diagrams. I'd like to see whether we can, the relationship between multi and this and string diagrams and so on. It's kind of the direction. All right, we should wrap up here. In a sense, by the time we've descended into combinators, we know it's time to wrap up.
All right, yeah, we'll
Supposed to be a
circle back
joke.
to some of these topics
Yes,
next time.
they're great topics. All right, thanks a lot, guys. See you all soon.